Notice I talked about sets of baseball cards or sets or collections of marbles, but obviously in a math class, most of the sets we're going to be working with are actually going to be sets of numbers. And there are certain sets of numbers that are much more standard or basic that are used all the time in mathematics, and that's what we're going to talk about now. The first basic set that we're going to talk about is the natural numbers. And what this set is the set containing 1, 2, 3, 4, 5, 6, and so on. I should really be writing set of natural numbers, but anyway, because I wrote it using braces. But anyway, the name for this, most of you will probably never see this outside of this lesson, but anyway, it's written as an N with an extra line down the left side. And the reason we write that extra line down the left side for the natural numbers is to show we aren't talking about any number or object, just happened to be given the name N as a variable, but this is a very specific set. This set written this way always means this collection, the collection of numbers 1, 2, 3, 4, 5, and 6. And notice I drew the dot, dot, dot called ellipses to show that there are an infinite number of them. There's no biggest natural number. No matter what number we're at, we can add 1 to it, like 5 and get to 6, 6 get to 7. It goes on forever. These are pretty obvious numbers. I think almost every culture has these numbers except for maybe very primitive ones. It's easy to see them in nature. There's a lot of agreement on do these numbers exist or not. Everyone can see, 4 trees, 5 apples, 6 cows. It's really obvious that we would consider them to exist and occur in nature. And one thing I do want to point out that's kind of odd, I used to teach out of a textbook written in the United Arab Emirates, and their textbook actually said 0 is a natural number, so there may not be worldwide agreement on this, but every textbook I've ever seen written in the U.S. has this exact definition for the natural numbers. The next set is called the whole numbers. And it's actually almost the exact same as the natural numbers. Obviously, we use a W with that extra line to show it's now exactly the set of whole numbers. It's essentially the natural numbers, but you throw 0 into it too. And so now we have 0, 1, 2, 3, 4, 5, 6. And there are the whole numbers. Notice the whole numbers also include 0. Sometimes the natural numbers are called the counting numbers. The whole numbers are almost, at least that I've ever seen, also have the number 0. The way that I remember which is which, notice whole has an O in it, which looks a lot like the 0, and a lowercase l looks a lot like a 1. That's honestly, when I first had to memorize these, how I remembered which is which. And then we also have what is called the integers, the set of integers. And now we also include negatives. And this is actually written using a Z. Some of you probably were guessing that it was going to be an I, but we don't really like to use I as a variable in mathematics. I'm not going to get into why right now, but it's used for enough other things that we don't like to use it for that. This also includes negatives, and so it's -5, -4, -3, -2, -1, 0, 1, 2, and 3, and so on. So notice this is essentially, right here, these are the whole numbers, and now we also include the negatives, and we call these the integers. In case you're wondering why the integers have a Z, it's easy for Americans to think all math was created or discovered by people who spoke English, and the integers are actually, the Z comes from German. In German, the integers are named Zahlen, and that's where the Z comes from. Actually, more math, I would guess, is probably done by people who speak German than actually by people who speak English in history. So anyway, that's why it's a Z.